Yeah. Okay. Right. So, welcome everyone. This today is the first day. Okay, today is the first day of chemical calculation nights. Okay. Today, you don't want the tunes, right? Most of the things I will explain today, right? Chemical calculation night, day 1. Okay. Now, we are going to go from the beginning, chemical calculations. Putha, first of all, understand, chemical calculation is a part which is important for all the physical chemistry lessons, right? Whenever you want to calculate, this is very important. This is a deciding factor. This is not actually only a lesson, it is an important part for many areas. So first of all, if you don't understand this, if you can't do this well, you will lose many marks in chemistry. And also you will start to get an unusual fear, an unwanted fear in chemistry. So this is a program to make you thorough in this particular part. So this will help you to develop the other parts in chemistry. Right. So first of all, we start. Most of the people get mole with moles, right? So that's the biggest problem. Okay. So when they say moles itself, you get a like unusual feeling, mole, because you are not familiar to that. But when someone says gram, you don't feel odd because you are used to that. When someone say milliliter and liter, you don't feel odd. Why? Because you are used to that. But when someone says moles, Avogadro, you get upset. Right. First of all, First, I'm going to speak about two things. What is mole? What is Avogadro? So I'm going to start from there. Because most of the people's problem, the headache, was mole and the Avogadro. Okay. But remember, mole mean it is some amount. Avogadro mean that is also an amount. Right? Like if someone says, first of all, I'm telling other things also to put it neatly to your head. Right? Close. First of all, if I speak, 1 kilogram is how many grams? 1000 grams. Yeah, usual. But do you feel 1 gram? But you have a feeling of 1 kilogram. Or 1 kilogram mean you can imagine this much is 1 kilogram. So when you carry something, or you can say, is there 1 kilogram? This is 100 grams. This might be less than 1 kilo. Like you can get a feeling. But you don't have a feeling for moles. Or you don't have a feeling for Avogadro. The real scenario starts here. These moles and Avogadro, actually, they have used in chemistry. But actually, you can use this in your real life also. But to use in real life, we don't have any things for this. Why? It's like this. What is 1 mole? 1 mole is Putha. Meaning of 1 mole is when this much of things, I can now, you have an idea like before 1 mole, like for 1 kilogram mean, you know, when 1000 grams joins, that is 1 kilogram. You have an idea like this. But if I ask how many milligrams in this, what will you say? 1 kilogram, 1000 into 1000 kilo, you will say 1 million milligram in this kilo, you will tell a measurement. Okay. Because 1 kilogram, there are 1 million milligram. Then someone asked, how many micrograms are in this? A person will tell 1 kilogram has 1 billion micrograms. Okay. We'll stop the game. Okay. You can understand this now? Because 1 kilo is 1000 gram, 1 gram is 1000 milligram, 1 milligram is 1000 microgram. Right? Okay. Now, if I say like this, 1 mole is Buddha, 1 mole mean actually this much of numbers, 6.022 into 10 to the power 23. This much of number is known as 1 mole. Okay, when this much of molecules join together, we call it 1 mole. But when we say molecules, you don't get a feeling. But if I say like this, okay, how many people living on earth now? What is the population? Population is 9 billion. 9 billion mean, if I write this as a power, now the current population, 9 into 10 to the power 9. This is only the current population. 9 billion people. Right? Then, if I take, we'll think for 100 days, every 100 years, every year we get, now current total population to 9 billion. We'll imagine every year we get 9 billion people. Every year we get 9 billion people. Every year 9 billion people mean how many billion people will be in 10 years? Multiply this by 10. When I multiply this by 10, after 10 years, we'll imagine no one will die. 10 to the power 10 only. Even for 10 years, number of total people, only this much. Then see the Avogadro's number. See the how much it is bigger. I'm telling total number of people who are living here at the current moment. Every year, imagine, every year same number of people will newly produced in the world. Every year 9 billion people will come to the world. So for 10 years, if you want to see for 10 years, what should you do? Multiply by 10. Then still you are going to get 9 into 10 to the power 10. Then 10 to the power 23 in, like how many years you have to spend? Even 1 billion years is not enough. So can you see the size of this amount? Can you feel it? 10 years, it means for the 10 years people also not enough to make it equal to number of Avogadro. They can make it equal to the number of molecules in 1 mole. Can you understand? Okay. So first understand what is number of molecules. Like how big is it? And just it's a number. So I can't use number of people to explain this. Okay. Just imagine lots of people came to this world from day 1 to until the world's end. Just imagine after world's end, people will go to heaven and hell. Now you're asking God, how many people have gone to heaven? God is replying, 1 mole of people. 1 mole of people have gone to heaven. Now you have learned chemistry, no? You will understand, this much of people have gone to heaven. This much of people mean? Can you tell this number in words? 6 billion කියන්නද මේක? 6 trillion කියන්නද? කොහොමද කියන්නේ මේකට? Can you tell this number in word? We haven't learned that. How to tell this in word? Have you learned? Anyone knows here how to tell this number in word? Just imagine this is your bank deposit. No need to learn anything. No need to learn chemistry. Okay. All right. So remember, now you're asking the same reply from God. Another question. How many people have gone to hell? God will reply, 99 moles. 1 mole has gone to heaven, 99 moles have gone to hell. Okay. No, that's the nature. Out of every 100, 99 will go to hell, 1 will go to heaven. Okay. Again, most of the people are criminals, no? Right? That's the nature. Right? So 99 moles mean what will happen? You have to multiply this number by 99. Then you get the answer who have gone to hell. How did you understand this? Now can you understand what is this Avogadro? So 1 mole is, so every time we can't write this big number, no, 6.022 into 10 to the power 23, 10 to the power 23, we can't write. Always we can't write the number of molecules in this pattern. Therefore, I can tell the number of molecules in this way. Okay, 1 mole. There are 1 mole what number of moles scale if I say, right? There are 1 mole. But if they ask how many molecules are in 1 mole, okay, this is the number of molecules in 1 mole. 6.022 into 10 to the power 23. Now understood the relationship between the Avogadro and the mole? From this, now we can do some basic connection. First of all, you have to understand this. This is a very big number, large number, because we can't tell this large number every time. Therefore, they have introduced a unit called mole. Because every time we can't tell, now if someone asks your mass, will you tell in grams or kilograms? You will tell you are 85 kilos scalar. Right? When you say 85 kilos, have you ever said I'm 85,000 grams scalar? What others will think? I'm 85 million milligrams. But a Mongol kila, right? Just tell and see when someone asks randomly, what is your height? You will tell 150 centimeters. That is okay. 1500 millimeters. Right? Odd. When we don't say in large things, we say in small things. Right? That's what we say. I'm 85 kilos. Right? Only the people will speak with the smallest unit. Normally we say that's why 1 mole kila we say. Okay, then they ask what is the amount of substance here? 1 mole. It means this much of molecules in this. Is it 100% clear now? What is this connection between the moles and Avogadro? So who found this number? Avogadro. So as a respect, we tell this as Avogadro constant. Avogadro constant. So this is the relationship between number of moles and Avogadro. Right. So first thing, you can write this. Okay. Again, how many numbers are there? Normally this Avogadro constant, you know how we write this? When we are writing, we write like this. Avogadro constant equals 6.022 into 10 to the power 23. After writing this, we say per mole kila. Why we say per mole? It means every mole you have this much of numbers. That's why if someone asks what is the unit of Avogadro, answer is per mole. Every mole you have this much of numbers, number of molecules. Okay, so hereafter don't get scared for number of molecules. Don't get scared for number of atoms. Don't get scared for number of substance, grams. Don't get scared. We'll do it slowly. Hurry. First of all, right. Okay, to explain this is big understanding here, although I took time for this. This is a very big thing. Okay, most of the time you don't know the proper meaning here. Right, Taggala write that. Okay. We are using only a small time. Every day we are doing chutta chutta. Chutta chutta will pour this to your head. Then finally, you will be a concentrated person in calculation. Okay. Right. Then this part is okay. Now we'll do few questions related to this, where I have given certain questions in this one, but before that I will tell few formulas. Today the introductory part Therefore, if we can, we'll try. If we have time, we'll go for questions. But we do all these chemical calculation questions based on three main formulas. Mainly based on three main formulas. Okay. Again, first of all, we say N, simple N equals simple M over capital M. Okay. Here, what is N? Number of moles. The unit is mole. Simple M mean mass, that is given in grams. Capital M mean molar mass. Capital M mean molar mass, that is given in grams per mole. Right. So these are the things we have given. Again, a number of moles, then grams, mass is given in grams, molar mass mean grams per mole. And there is another formula, capital N equals N into capital L. This capital N, we say number of atoms, or I can say number of molecules. Okay, number of atoms or number of molecules. N mean number of moles, Capital L mean Avogadro constant. Number of atoms, no unit. Number of moles, mole. Avogadro constant given in per mole. Right. So this is the other thing. This is the second equation we use. Number of atoms we can say as number of molecules we can say. Number of molecules. Okay. Water molecules. Okay. Okay. Then next one, they will ask you the concentration. There is a thing called concentration. Concentration you can measure using this formula, C equals N over V. This is also very important formula, right? Concentration, C mean concentration, N mean number of moles, V mean volume. What is V? V is volume. So these things we write like this. Volume, we don't give in standard values here. Normally we use decimeter. Number of moles we use mole. So concentration comes as, again this one is moles no puta. This one comes as moles. Right. This one we write as moles. This one we write as decimeter. So when you divide mole by decimeter, you get MOL dm minus 3. Right. Mole divided by decimeter, MOL dm minus 3. Right. And you should understand the connections of this. I will give time to write. Main thing here, more than writing, first try to understand. Again, you can see the recordings, and because this is available in YouTube also, no? In order to write the notes, or you can use that. Time will try to use for complete understanding. So if you try to write here, we have some time issues, right? It is our writing part. Get the note. You all complete. Half an hour you watch, you can complete the note. Right. Then Puta, this concentration, number of moles, volume, everything are here. Right. Then normally you should know the connection between this. Decimeter cube. Again, we have unit called decimeter cube. This decimeter cube, actually this is liters. This liters only known as decimeter cube in chemistry. Normally we use decimeter cube normally in chemistry. Mostly other places I don't think you see this unit. Physics and all, are they using decimeter cube? Mostly. No, no, mostly they are using meter cube or centimeter cube. But decimeter cube, mostly we are using in chemistry. So decimeter cube and liter mean both are same. If someone say liter and decimeter cube, both are same. Centimeter cube and milliliter, both are same. Then same way you have to convert centimeter cube to decimeter cube. So if you want to convert, okay, if you want to convert centimeter cube to decimeter cube, what should you do? What should you do? Multiply or divide? Divide by 1000. If you want to convert centimeter cube to decimeter cube, you have to divide by 1000. If you want to convert decimeter cube to centimeter cube, you have to multiply by 1000. Right? Normally we don't use meter cube here, but if you have meter cube is equal 1000 liters or decimeter cube, because both are same. So these are the unit conversions you should understand. Normally any unit conversion, this will be helpful. Okay, this will be helpful for anything. Okay, for any conversions. Okay, BMSD. Okay, BMSD. Okay, then how you remember this? Okay, again, what's happening? Big unit, a big unit. When you want to convert to a small unit, you have to multiply this. When a small unit want to convert to a big unit, you have to divide. And you have to remember this. You know we have given so many mnemonics for this BMSD. Right. Okay. So you ask from the people whom you know. So remember, this is the way. Okay. BMSD. Okay. BMSD. What you have to do, big to small you have to multiply, small to big you have to divide. That is it. In the cycle, you just remember. Okay. You try to make a good mnemonic for this. Already there is a ready-made mnemonic. I think always we can't tell because this is a YouTube live. We think right. So understand that. Right. This part is okay. So here small to big, it would divide. You have to remember in this order BMSD. BMSD. Okay, BMS. You have heard that campus, no BMS scale? Okay. BMS Deval. Right. You just remember BMS campus. BMS Deval. Okay, it don't have the mnemonics, but you personalize your mnemonics, right? Anyhow, certain mnemonics we won't tell further, right? Right. That is fine. So did you understand these conversions now? Do you understand the formulas? Right? You go home and complete this note. Go home and complete this note. Right? So we are going to do the entire thing based on this. Okay? We are going to do entire thing based on these three formulas. Okay. Then do you have the tute? Chemical calculation night tute 1. If you have, you all can take it. Gun we'll try to share that. Right. But we have only 4 more minutes. Anyhow, 4 more minutes walata hari kamak naha. This we'll see this. Okay. Okay. එතනට දාගන්න පුළුවන් ද ස්ක්‍රීන් එකට. The duty is in the Google form. Google form name, I'm sorry. It's there. ඒක තියෙනවා. It is in our channel. Right. මේ Then I'll open that. එක question එකක්වත් කරත් you will be happy, no? Right. Because now I put the foundation to do the questions, right? May okay. Now we have opened. Right, we could open that. Now I'll share that photo. We'll take around 5 minutes, 35 කිව්වට 40 වගේ ඉවර කරත් කවුරුත් තරහ වෙන්නේ නැහැ. And finish this, at least we'll do the first question. So see this under chemical calculation, Knight's first one. How many moles are present in 16 grams of oxygen gas? The second question, calculate the number of moles in 36 grams of water. Right? I guess everyone knows to do. But initiating a question, I think we have to do everything. But you will get a better knowledge when you're continuing this. All those small things, you will do it together. So 16 grams of water. Sorry, 16 grams of O2. Okay. How many oxygen moles are present in 16 grams of O2? How to do that? Now, first of all, when you're doing a question, 16 grams of O2 is present. And they have given relative atomic mass of oxygen 16 kg. Right? Relative atomic mass means that is relative to carbon 12, that is the mass of oxygen. Otherwise everything will miss. Okay. So this is only molar mass. Whatever given here is molar mass. This is molar mass of one oxygen, but O2's molar mass is, we have to write like this, capital M O2. These are about when we are writing this. One oxygen is 16, then two oxygen mean we have to write 2 16s. We can write 32 grams per mole. I can write the unit. That is the molar mass of O2. Then I can write simple N equals simple M over capital M. We have to use this formula. Simple M is how much, Putta? 16 grams. For simple M, I can use 16 grams. Normally in chemistry we have to write units. Okay, for each and every step we have to write unit. Capital M means what? 32. Then 32 grams per mole. What will happen? 16 divided by 32 pin Putta. 16 and 32 I can divide 1 over 2. Then answer is 0.5 moles scale. I can finish this game. So this is the answer for the number of moles. Okay, it is very simple. Question number 2, they have asked how many moles of oxygen, how many moles of water are present in 36 grams of H2O. When you take 36 grams of H2O, they have given H is 1, O is 16, right? So I can write capital M H2O. As a capital M H2O, I can write, there are two hydrogens, so 1 into 2, right? I can write 1 into 2 plus oxygen is 16. So already I will get 18 grams per mole. It means this is the molar mass of water. So to find the number of moles, N is equal simple M over capital M. So simple M, I can write how much? 36 grams. Capital M, I can write 18 grams per mole, right? 18 grams per mole. Then 36 divided by 18 mean I get 2 moles. Okay, so these are some basic structures. Again, you should understand with this how many number of atoms might be there in this small amount. Again, can you understand, Buddha? Again, 36 grams of water. Again, a small amount of water amount. Normally, we are taking grams and milliliter equal to water. 36 milliliter water. See how many molecules are present in 36 milliliter of water. What you are drinking. Just see how many molecules of water are present in it. 6.022 into 10 to the power 23, 2 times. Understood the value? Okay, because so many invisible things are there for our eyes. I think we'll continue with this invisibility, right? So next question is, I think third question, if you would have seen, it would have come with standard temperature and pressure, some question related to that. Next week, we'll see what is that. Okay, so we'll continue this journey, okay, with chemical calculation nights. Okay, we'll wind up. It's right.